My name is Sherry Warren. I'm with CCOR. CCOR, for those that are unaware of it, is a research and development organization affiliated with Memorial University of Newfoundland in St. John's, Newfoundland. So before I start, I'd like to say hello to my colleagues on this project who are in Berlin right now. Camilla just spoke, is actually a person that's working on this project team with me. And I'm not sure if Oliver Lang is still there. Oliver gave a presentation this morning during the Airbus tour. So I'd like to say hello to greetings to these guys also. Okay, so I will start to talk about tactics. As we said, tactics is the tactical tracking of icebergs and ships in sea ice. So Camilla's talk really, I guess, introduced my talk because she introduced ships getting caught in ice, which is, ice is a major hazard to ships, to offshore oil and gas, and so she just gave an example of where ships can be caught in ice and ice bridges for many weeks. So Tactics is a project that is funded, it's an international research and development program that's funded by the Canadian Space Agency in collaboration with Airbus Defence and Space, and their component is called ShipTAC, and it's also funded by the German Aerospace Center, DLR. And so that's in Potsdam is where my colleagues are located. So I'll go over the, I guess, the main project objectives. The first one being, considering this is funded by the two space agencies, it's trying to encourage collaboration between people like myself who work in Earth observation, so Earth observation companies within Germany, within Canada. And I guess the basic main objective of this project is to advance the capabilities of C-band SAR, which is Canada's RadarSat satellite, which is the second Canada's second radar satellite, and also X-band satellites called TerraSAR-X and Tandem-X, which are two of German's SAR satellites, SAR being synthetic aperture radar. So, and the main thing is to use the combination of these SAR satellites to detect ships and icebergs in sea ice, also in using conjunction with AIS, which is automatic identification systems that are on board ships to record their positions. So this project, I'm going to talk about some preliminary results that we have with this tactics project, but I'm also going to present some slides that talk about other research that we've done previously. So two of my three previous projects that I've involved with are X-ICE, which was called Detection and Monitoring of Extreme Ice Features in the Canadian Arctic, ICeSAS, which was a space-based AIS for ship and iceberg monitoring. Both these projects were also funded by the Canadian Space Agency. And a third project, which was an industry project funded by oil and gas, looked at the investigation of using high-resolution optical satellites for the detection of sea ice features. So the problem, as Camilla was just talking about, ice is a major safety issue and hazard. So the problem is actually, and it's a difficult problem, is detecting targets in ice, whether that be ships or icebergs. So shown here, there's an iceberg in the middle of sea ice. This is like a pancake type ice, but it is very difficult. And of course, as we know, the ocean is very vast, and being able to monitor these is where satellite SAR comes into play. And in this one here, you can even see how difficult it is to visually detect an iceberg by the human eye by using, say, optical satellites, which is hence why we rely on satellite SAR to monitor ice here in Canada. So tactics in general, we're looking at the performance of X-band and C-band SAR to enhance targets, to try for us to better detect these targets in sea ice. Also, we're looking at trying to improve the classification accuracy of ships versus targets, so other false alarm targets, we call them, which would be other sea ice features, icebergs, and sea ice. And also, we're looking at the ability of a multi-mission approach, which is, like I've said before, using a combination of different SAR-band satellites to develop a vessel tracking history using AIS. So the major challenge, I guess, that we're focusing on is in this project is the lack of data sets, and we're talking about ocean data sets, and ocean's a very vast place. So the problem we have is a lack of known iceberg locations or known, well, ships are pretty good to get, but actual validated sea ice features. So we have a lack of those data sets to try to develop these algorithms. So the sources, the ground truth sources that we look to use for are from government sources: Canadian Ice Service, International Ice Patrol, shipping companies that are traveling in the Arctic, and oil and gas companies. So the main statement of work, like I said, we're doing this in collaboration with Airbus in Potsdam, mainly, and the project started in the summer of 2015. It goes until May 2017, so we have about 6 or 7 months left in the project. The 4 main tasks in the statement of work, and these are some of these tasks are shared between us at SECOR and Airbus. So the first one is discrimination of ships and icebergs within sea ice. The second one being data mission acquisition, with Airbus and SECOR also working jointly on this task. And the third one being vessel tracking after detection. That's mainly Airbus's responsibility. And the fourth one is the ship and iceberg detection and discrimination using combination of TerraSAR-X and TandemX data. And that's both our shared work package. So I want to highlight in this project that this is it's been a very successful collaboration between us and Airbus. The RadarSat imagery is being provided by the Canadian Space Agency, and the TerraSAR-X imagery is being supplied by DLR, the German Aerospace Center. And so we're sharing our project results, we're sharing data, host monthly teleconferences, and so everything is going very well. And so the next slide just talks about the actual information that we're trying to extract from satellite imagery and other ocean data sets. These 5 sea ice types or information is actually from the Canadian Coast Guard for what they're looking for information from the ice to help them navigate better through the ice. So the first one being ice types, which varies from slush ice to solid pack, ice deformation features, pressure ridges, rubble, hummocks, rafting ice parameters like thickness, concentration, strength, large features of old ice, so older ice has higher backscatter, and icebergs. So there's a lot of detailed information that we're trying to get that are important for navigation. So I just threw in this slide, hence we're talking about ocean data sets. Probably all of these are being used in our tactics ShipTac project, but probably not the altimeter data, as it's a little too coarse. So the first one being the optical and radar satellite imagery, which I'll show you some examples of. The AIS ship data, which gives us the exact ship locations of larger ships. Satellite altimeter data, which can give you height information and information on ocean features in general. Field information collected from sea ice from ships, so that's people being on ships and recording the types of sea ice, if there's an iceberg at this location or what type of sea ice it is, and also marine radar data from ships. So the whole problem of iceberg detection in sea ice. The problem, as you can see from the top slide here, is that's an iceberg in sea ice, so you can hardly see the iceberg. The problem is these iceberg targets have similar radar signature as opposed to the surrounding sea ice. In the bottom one, you can clearly see the iceberg more visible as it's in open water. So the approach that we take, and we've been doing research on ice and icebergs for several years, probably almost, 15 to 20 years at SECOR. And so we developed many techniques over time. So we look at visualization techniques using polarized imagery. So RadarSat-2 is a fully polarimetric satellite, so that gives us a lot of extra capabilities. Improved detection algorithms and quality control. So here's an example on the top. You have some icebergs. I don't have a pointer, but you can see the blue circles. They're all icebergs. So the top image is actually a very high resolution image of icebergs in sea ice. It was collected by a commercial US satellite called GOI. It's about 50 centimeters resolution. And the other one on the bottom is a RadarSat-2 fully polarimetric image. And you'll see the circles and all the icebergs are highlighted in green. And so we use different, RadarSat-2 has 4 polarizations. So this HH, HV, VV, and VH. And so here we have at the bottom we have a color composite with the red, green, and blue channels and the different absolute values of those that shows that we can extract icebergs more effectively using polarized imagery. This is a previous SECOR project that was using TerraSAR-X dual pole. So unlike fully polarimetric RadarSat-2, TerraSAR-X offers dual pole capabilities, which are also very powerful. The image on the left, the red is the land, the rest is ice and sea ice. The HH image, that's the one, the first channel there. You can see that the iceberg is the red feature on the right. The blue is like open water. And then the next target, you can see that the next image showing is a target showing the iceberg being extracted. Now, this is done automatically with classifiers that other engineers at SECOR have developed. And so the HV channel, you can see that the iceberg comes out a little bit more. It's a little bit smaller, but often in sea ice and ice imagery, HV can be a powerful channel to extract different images. And the last image basically just shows this algorithm that one of my colleagues developed, which basically shows if you have an image and a pixel it shows up in the yellow area, then it would be classified as an iceberg. If it shows in the green area, then it would be classified as like ocean backscatter. Another previous project that we've had at SECOR is investigating the use of AIS and how ship data can improve our iceberg classification. So basically, we've confirmed in this project that the accuracy and reliability of AIS data, obviously brings a lot to it, as shown in this table. So you can see here on the right, it says the accuracy percentage without the AIS data, and then the one on the left would be the one with it. So different channels. So you can see it broken down by HH, HV, and then the dual, which is the overlapping parts of the image, and then the dual all targets. So you can see that the dual, using a dual pole combination can bring, and using AIS, can actually increase your classification accuracy from around 71% to 95%. So we've shown, and that's why we're using AIS data in tactics, because this additional ground truth information is very powerful to actually know where the ships are, and then we know that they're not icebergs. This is another previous slide from a previous project called X-ICE that I introduced earlier. These are two fine quad radar set 2 images. So we basically had 2 images, and we made a stereo image of the icebergs. And so you can see all of the icebergs extracted here, and the elevation going from blue to red is the higher. So by doing the stereo imagery, we can extract the height, which can give us indications of the icebergs, the locations and the heights. So interferometric means by Tandem X. Tandem X is a German basically twin satellites that collect the same area. So it's 2 satellites collecting the same area over the same time. And this has been used for global topographic mapping, as can be seen on the right graphic. So we're actually using this type of technique. We have in previous projects, and we're using it under tactics. So basically, you have an image here, and in the middle you have the phase, so the height is extracted from the phase. And then over here on the right, you have various icebergs. There's like 4 there. So we can also use this technique to extract height, to extract icebergs. So talking about Tandem X again, a recent mode, I guess, that they have is biostatic data. So you have 1 signal going out and then 2 signals coming back to produce this lovely image. This is actually a Tandem X image near Baffin Bay that was collected under tactics. So you can see the land here is in the gray. You can see some large ridges here, and then you also see icebergs in sea ice. So we basically take this imagery and we create a digital elevation model, which helps us to also extract the icebergs in sea ice. So basically, like I said, we have 6 or 7 months left to our project. The project results to date are very, very good, very promising. Iceberg detection in sea ice shows promising results, like I said, with the RadarSat 2 polarimetric data. The classification accuracy of ships and icebergs in sea ice is very high, so it's very good. We still have some TerraSAR X and Tandem X imagery yet to be processed, and also some more Tandem X biostatic capabilities. The ones that we have seen are excellent, and we still have work ongoing until May 2017. So that's about it. So thank you very much for your attention.
As before, thank you very much, first of all, for your presentation. And as before, I'm open up for short questions for understanding before we continue with Mrs. Bischoff-von-Schott. I have one question here in Berlin.
Sure,
Please go ahead.
speech. My name is Jeff Rabbit from Rolls-Royce. I want to ask you, what would be the implications of operating
That's a good question. I'm not really sure. I mean, obviously that would be a less safety hazard to humans. I don't know if there's anyone from the Canadian Ice Service here that could probably answer that question better than myself. To me, it would obviously decrease safety. But I mean, it's a lot to develop these ships, you know, but obviously might be, you know, some out there. I'm not really directly from the shipping industry, so